everybody, welcome back to Human Resource Machine. Last time we finished the first 15 levels, so let's continue on to number 16, Absolute Positivity. Aha! Positive attitudes were determined to increase productivity and are now therefore mandatory. Smile! Management is watching. The task is send each thing from the inbox to the outbox, but if the number is negative, first remove its negative sign. Okay, so let's start this. Each thing from the inbox to the outbox. So we want to test if it's negative first. Jump if negative. If it's negative, we want to remove its negative sign. We can do this by using 0 and subtracting the negative number. I imagine you need to copy the number to the floor, and then I'm thinking about how to get 0 in my hand. If this was a real computer, I would be able to, let's say, pick up from an empty spot, and that would contain 0. I don't know if that works in this game, but the other thing I can do is just to subtract this. So I'm holding, let's say, 8, and I'm copying 8 over here, and I subtract 8. So a number subtracted by itself is always going to be 0, and now I'm going to subtract that number again, which gives us the negative version of that number. And this is what I want to send to the outbox. Jump if negative, that's the negative case. If it's positive, I would want to just immediately send it to the outbox. And I would jump back. Okay, speed challenge, yeah, I know. So let's try to do that thing where let's see, can we just move this part up, move this over here? I don't think that'll help because it's still the same number of jumps. Oh yeah, here we can use one of the earlier tricks we used. So instead of jumping, outbox, and then jumping again, which is 3 instructions, we can have it directly go to the outbox and then jump back to the beginning. That way we skip one jump, which is going to save some time. There you go, we got the speed challenge. Okay, number 17, Exclusive Lounge. Yes, I've always felt most comfortable with nice, cold, logical decisions. Emotional decisions are for the weak. The problem is, for each 2 things in the inbox, send a 0 to the outbox if they have the same sign, both positive or both negative, or send a 1 to the outbox if the signs are different. Repeat until the inbox is empty. Okay, so I imagine we'd have to test both numbers. So we're going to have a whole bunch of jump if negative instructions. Let's try this. We take a number from the inbox. If it's negative, we want to do something. Let's take another number from the inbox. I'm just working on the negative case. So if the second number is also negative, then they have the same sign, and so I want to send a 0. So I want to copy from a 0 and send that to the outbox. This is if they're both negative. So let's do the second number. So if the first one is negative and the second one is positive, then we end up here. In that case, their signs are different, and I would want to copy a 1 and send that out to the outbox. Of course, jump back to the beginning when I'm done. Alright, so we got 2 of the cases taken care of. For the first number, if it is positive, let's test the second number here. If the first number is positive, but the second number is negative, that means they have different signs, and so I need to send a 1. one is in slot 5, so this is right here. Yes. Okay, if first number is positive and second number is also positive, then we can copy from 4 to get a 0, send that to the outbox, and then jump back to the beginning. I think the logic is correct. I'm sure it can be optimized some more, but let me just test it first. Okay, we got the speed challenge. That's what I expected because I've been optimizing the number of jumps. But the size challenge, obviously, we used more commands than we needed to, so let's optimize that. What I'm thinking is we have a lot of duplicated instructions. For example, here we have copy from 4, here we have copy from 4 again. So if we can remove some of these duplications, then we can save some space in our program. So what I'm seeing is one of these branches is jumping over here to a copy from 4. Instead of jumping over here, maybe we can have it jump up here to use this copy so that we don't need to maintain this copy over here. And also, this one, instead of sending to the outbox and then jumping back to the beginning, we could have the jump instead go over here so that it uses this outbox instruction and then jumps its way back to the beginning. And we happen to have, two jumps both going to the beginning, so we can remove one of those as well. Let's test this. There you go, we did better than requirement. Coffee break, Sabbatical Beach Paradise. Okay, next, number 19 is countdown. Yes, welcome back. Tick, tick, tick. Time keeps ticking down. Let's get to work. Oh yes, I love what you've done with your hair. Okay, what did I do with my hair? For each number in the inbox, send that number to the outbox, followed by all numbers down to or up to 0. It's a countdown. You get new commands, add 1 or subtract 1 from an item on the floor. The result is given back to you, and for your convenience, also written back to the floor. Bump. Alright, let's figure out how this works. The bump command, add 1 or subtract 1 from an item on the floor. Okay, so I have to have an item on the floor, and then I can bump that, and it changes both the number in my hand and also the floor at the same time. Okay. And I need to make it work for positive and negative numbers, so obviously I would need 2 branches. So let's get a number, test if it's negative. If it is negative, actually, let's copy it to the floor no matter what. Now if the number is negative, I'm going to want to bump it up. Bump this up. Oh, followed by all the numbers down to or up to 0. We have a problem if it starts with a 0. So let's test that first. If it is 0, then we want to send it to the outbox immediately and skip all the bumping. If it's not 0, now we can do our bumping. If it's negative, we want to wait. For each number, send that number to the outbox, followed by all the numbers. Okay, never mind. Send it to the outbox first. So we need a copy of the original number. And then if it's now 0, we can just restart. We don't need to do any of the bumping. Now if it's not 0 and it's negative, we can finally get to our bumping. So we can bump the number up, and I think we can do this because we bump the number up. So now we have the number +1. We send it to the outbox. If it's 0, we can stop. If it's still negative, then we do the bumping again. Yeah, I think that'll work. Now if it's not negative, we need to bump the other way. And similarly, jump our way over here. That's right. Uh-oh. Empty value. You can't jump if 0 with empty hands. Oh, okay. Okay. Yeah, this is the mechanic that they didn't quite explain, but once you put number in the outbox, you don't have a number in your hands anymore. So I guess we'll have to copy from this. Every time we put something in the outbox, we make sure we get another copy from here, and the rest of the bumping should be okay. Okay, looks like everything's going very well. Speed challenge. Complete in 82 or fewer steps. How does that happen? Well, for one thing, jump if 0 and jump if negative is kind of redundant, because if we know the number is negative, if we test for negative first, and we know it's negative, then there's no point testing if it's 0. It cannot be 0 when it's negative. So if we move this down here, then jump if 0 will only be executed if the number is not negative. That should save us some steps. I don't know if it's enough to meet the challenge, but it's a start. No, we're still way off. Okay, let me rethink this. So I think our main problem is with all these jumps. So we have like jumps crisscrossing every which way, and that is probably the reason it's taking up too many instructions, because everything else is absolutely essential. We have to take stuff from the inbox, we have to store stuff, but we have to bump the numbers, so everything else is essential. And I think the main goal is to reduce the amount of jumping that we have to do. Oh yeah, one thing I'm noticing is, see if our number is negative when we come to this branch. When we jump again, there's really no point testing if it's negative again, because we know it's not going to turn positive. The only thing it can possibly do is turn into 0. And so we can skip some of these testing, I think, by copying some of these instructions down. So after bumping, we still want to send it. Normally after bumping, it would have jumped over here, send it to outbox, and copy it again, and test the number again. So I'm going to do the same thing here. And so now we don't need to jump all the way up there, we just need to jump back to the beginning here. Except we also need to test if it's 0. So after copying, test if it's 0. If it is 0, then we are done. And we can go back to the beginning. I think that's it for the negative loop. Now the positive loop, we can do a similar thing. Here it'll jump up to outbox and copy from, so I'm gonna put these things over here. Copy from 0, and then instead of jumping up here, because we've done these already, we can jump directly here and test if it's 0. So there's no point testing if it's negative, because a positive number is never going to turn negative. Okay, let's see how much that improves things. Yeah, see, now it's making a much tighter loop as it does this. it's not jumping around so wildly anymore. It's probably only executing one jump instruction per loop. 100. Oh. Well, it's better than before, but still not as much as we'd like. So let's see what else we can do. So one thing we can leverage is the fact that when we bump a number, it also puts that number into your hand. So this copy from is kind of redundant. The only reason we were doing that before is because we send the number out to outbox, and once we do that, we don't have a number in our hand anymore, and that's why we need to copy the number again. And so if we do the jump if 0 test before sending it to the outbox, then we don't need to pick up the number again. So let's do this, jump if 0, and if it is 0, we need to end our loop, but we need to make sure to send 0 to the outbox before we go back to the beginning. So let's do this, jump to the end, send our last number, send 0 to the outbox, and then jump all the way back to the beginning. And then this jump can come over here. You don't need to test if it's 0 twice, because we've already tested if it's 0 down here. Okay, hold on. If it's negative, it goes down below. We can ignore that for now. If it's initially 0, it just immediately goes back to the beginning because we've already put 0 in the outbox right away. If it's initially not 0, we would have put, let's say, 1 up here. It goes down here, bumps it by 1. If it's now 0, it puts 0 in the outbox and goes up. That's good. If it is still not 0, it sends it to the outbox, jumps over here, bumps it again. Okay, I think this is correct. And similarly for the negative loop. So if it's negative, it comes back here, and then we don't need to copy, but we test if it's 0 before sending to the outbox, and the destination for that should be down here. So bump, jump if 0, go down here, out, jump back up, bump, jump if 0 down here, outbox, jump. Okay, let's test it. That should be much better because it doesn't have to copy from every time. 85. Okay, we're getting close, we're getting close. Just need a little bit extra improvement. Alright, how about I just pull the old trick? Instead of jump if 0 and then jumping again, so 2 jumps per loop, I'm gonna unroll the loop a little bit. Bump, jump if 0, outbox. Make sure the jump if 0 has the correct destination. Okay, unrolling this loop, and then similarly over here, bump, jump if 0, make sure it has the correct destination, outbox. Okay, now it should execute, I don't know, 25% fewer jumps. Come on, come on, come on, come on. Yes! Yes! Got it, finally. Alright, that was pretty challenging. Next one, multiplication workshop. It seems like only yesterday we were learning about adding. Fond memories. We worked so hard back then. Alright, for each 2 things in the inbox, multiply them and outbox the result. Don't worry about negative numbers for now. You got labels. They can help you remember the purpose of each tile on the floor. Just tap any tile on the floor to edit. Okay. 0, hello. Yeah, these are the labels. Let's remove them for now. we need to multiply. We don't have a multiply instruction, so we're going to have to add repeatedly. So like 4 times 4 is going to be you add 4 with 4 with 4 with 4, a total of 4 times. And the way we keep track of how many times we've added is using bumps. So this is total junk. I don't want that. Let's go. Pick up our first number. Let's say this is the counter of how many times we need to add. Let's copy that to this one, and let's make this like count. We take another number, copy it to here, and let's call this our, okay, let's just call it add. I don't know what to call it. And then let's label this one our sum. And initially we want the sum to be 0. So copy from 0. Okay, maybe I should not have deleted that. Anyway, copy from 0 and copy that to our sum initially. So our sum is initially 0. We have the 2 numbers that we need to add over here. Every time I want to bump the count down by 1. And every time I do that, I want to take the sum, add the number that we want to add, and put that result back into sum. And I want to be able to repeat that. I want to keep bumping until the count runs out. And because we're bumping count before everything, so imagine if count is 0 initially, bumping it by 1 is going to turn it negative. So we do jump if negative. As soon as the count turns negative, we know we need to stop adding these. So we want to copy from sum and send that to the outbox and jump back to the beginning. Probably not optimal by any sense, and I'm not even sure if this is going to work, but I'm going to try it. Okay, seems to be okay. Okay, we got the size challenge. This is good. Speed challenge, we need to work on this. One thing I did notice, multiplying by 0. Multiplying by 0 should be very, very easy. So you should not have to do any of this crap if you're multiplying by 0. So take the inbox and we're going to immediately test if it's 0. So jump if 0 without even copying anything. If it's 0, we're going to do a special thing. If it's 0, we are just going to copy from 0 and send that to the outbox. And jump right back. So this is going to shortcut all of this program. Because when it was executing the last time, I was noticing it was adding 0 to 0 to 0 to 0 to 0, and the result is still 0. That's completely pointless. Yeah, that's the first one. And the second inbox, the second number 2. If it is 0, then skip all of this and do the same thing, copy from 0, send it to the outbox. The rest we should be pretty okay. I mean, maybe it's possible to optimize this again, but whatever. Let's test it. Ooh, management expected 8, but you outboxed 6. Okay. I might actually want to see how that went. Yeah, let's step back and debug because I don't know how that happened. What were the original operators? Okay, this was the last one. Oh, okay, I see. Yeah, we do need to pick up both items, because if this one's 0, then we actually skip picking up something from the inbox, which is not good. So we do need to pick up both numbers, so we don't get confused about which number we're trying to multiply. Okay, so inbox, this one. Jump if 0, it can't just stop here. We need to pick up another number from the inbox and just trash it before copying 0 and put it in the outbox. Let's try that. $144. Wow. Okay, we need to do much better then. Alright, so I'm thinking if we want to reduce the number of steps by something like 40 steps, then we have to reduce this loop over here, because everything else really doesn't execute that much. The inputs only make us multiply like 4 sets of numbers, and so the rest of the instructions either execute like once or twice, or maybe a maximum of 4 times. But this loop where we reduce the count and keep adding number to itself, this one is the one that takes up the vast majority of the steps. So I was thinking about ways to tighten this loop and maybe reduce the number of jumps, or maybe reduce the redundancy from copy to copy from, and all of that, but I couldn't really think of any way to do that. But if I can't reduce the size of this loop, maybe I can reduce the number of times that this loop gets executed. So one observation is if you have something like 8 times 2, you could add 8 to itself twice, which means you run through this loop 2 times. Or you could be adding 2 to itself 8 times, which means you'd be running through this loop 8 times. There's a huge difference there. So I actually want to find out initially, test which of the inputs is bigger, and I want to use the smaller number as the count to minimize the number of times it has to go through this loop. So that's the idea for now. At this point, I have count and add in these positions. So now I want to test which one's smaller. So I have add in my hands. I'm going to subtract count. That's correct. Let me just put something here just to note that the rest of the program is still how I want it. I'm still adding stuff here. Okay. Add, subtract count. Or actually, let me rename this. This is input 1. This one is going to be input 2. I got input 1, input 2. I took input 2, subtract input 1. And if it's negative, that means input 1 is bigger. And so I'm going to take input 1 and stick that into a new slot. I'm going to call this big. I'm going to copy from input 2, which is the smaller one. I'm going to copy it to this one. I'm going to call this small. And then go to our actual program. the other way around. Jump if negative. If negative should be down here. If it's not negative, that means input 2 is bigger. So I'm gonna copy from input 1. Now copy this to small instead. Copy from input 2 and put this into big. Okay, now we have the numbers sorted. We know which one's smaller and which one's bigger. And over here, instead of getting from input 1, I'm going to get it from the smaller number. That will act as the count. And instead of adding input 2, I'm going to add the bigger number. And that'll be the tracker for our sum. And the program is getting pretty big, but I'm hoping this will massively reduce the number of times we go through this loop and reduce the number of steps that way. $134, slightly better, but still not quite there. I'm starting to feel like maybe I'm making the program too big and I'm running too many instructions just to do the efficiency checks. And it's not getting me as much benefit as I thought. So let me remove most of this stuff and try to do things in a slightly funky way that you'll see soon. So jump if 0, this is the 0 check. I'm going to remove those. I'm not going to check which one's bigger. This doesn't matter anymore. I'm going to remove all of that. Don't need this anymore. This is how we originally had our program to initialize everything. Now, originally we had something like bump in 1. This was our count. We bumped it, jump if negative, otherwise add the other number to sum. Yeah, and this is how we had it. These ones don't really matter. These are the when I was testing for 0. The change I'm going to make this time is after I added, oh, and it's not big. I want to add into. After I decreased in 1 and then added into, I want to now do the same thing but reversed. So now I'm going to bump in 2 instead. Do a jump if negative to the same location. And then I'm going to copy from sum. Jump if negative. Bump, jump, copy, and then now I'm going to add a copy of in 1. Copy of this to sum. And then jump back to the beginning. And then let me just run through this scenario to explain how this works and what I'm thinking. So first we initialize everything. So we got our 2 inputs, 1 and 3. Our sum is initially 0. So now we come in here and we do the first part. The first part we use in 1 as the counter. So we're adding 1 times 3. So we're going to decrease that. We add a copy of 3 into our sum. So originally we had 1 times 3. We added a copy of 3, and what's remaining is 0 times 3. So far so good. And now for the second part, we're going to reverse roles. We're going to use this one as the counter. So now we're adding 3 times 0. So he's going to come over here, reduce this one, add 0 to the sum, and this is our new sum. So 0 times 3 became 0 times 2, and we've added 0 to the sum, a copy of 0 to the sum. And by doing it this way, whichever number is smaller is going to run out first. So this one was a 1, now it's a 0, and on the next iteration, it's going to get reduced to -1. And this one is going to run out first because it's the smaller of the two numbers. And as soon as this runs out, we go to the end of the program where we output the sum. And if in1 had been a big number like 8, and in2 was a smaller number, then in2 would run out first. It would also terminate the loop early for us and give us the correct sum. At least that's the intention of how it works. This serves as both a 0 check for both of the items, because if either one of these is 0, then as soon as we start decreasing any one of these, then it's going to terminate the loop. And it also serves as a smaller greater check for these, because we're decreasing both of these at the same time, so whichever one's smaller will run out first. Let's see how this goes. Oh, that's way worse. Here's a thought. Right around here, when we're comparing which of the inputs is bigger, we're actually doing a lot of work before we even get started on the adding part. So I want to try to reduce this, and I have an idea. So instead of writing out which one is bigger and which one is smaller, what I can actually do is jump if negative means input 1 is bigger, so we want to use input 2 as the count. So let's go to our actual loop, use input 2 as the count, and input 1 as the number to add. So now we don't have big and small anymore. We don't use these. We never write those. It's just if we find that this subtraction is negative, which again means input 1 is bigger, then we go to this loop, using input 1 to add and input 2 as the counter. And if it's not negative, then we're going to do something else while skipping past all this stuff. So in the positive case, we know input 2 is the bigger one, and so we're gonna do all of the same things. Copy from 0, copy to sum, bump minus, except this one we're gonna bump minus input 1, because now we're using input 1 as the counter in this branch. Jump if negative. Copy from sum, add, except this time we want to add input 2, copy to sum. What else do we have? Jump back to the beginning before we bump. Like that. Looks kind of reasonable. Okay, so this is so that we can skip all the work setting up these cells. We can just use input 1 and input 2 directly, and except we swap their usage in 1, 2, 2, 1, depending on which branch we're in. Oh yeah, also here, there's no reason to copy from 0, because when we get here, we're already holding a 0 in our hands. This is because we just literally just tested that the input is 0, so we don't need that. Except here, if we get another item from inbox, then we need this. Copy from 0. So that saves one step in case the second number is 0. That should at least improve things somewhat. I don't think it's gonna get us to the target just yet. I think we can get rid of this comment. But let's test it and see how it goes. Okay, 121, we're getting close, we're getting close. We need it to be a little bit faster. The next idea I had is this bump and jump if negative. So we don't actually need to bump immediately and test before doing the add, because up here we've already made sure that neither one is going to be 0. So we can start doing the add right away, and only after that do the bump and jump if negative. Same thing here. Now the question is, how does that help us? And here's the other idea I have. Oh yeah, it's not going to be jump if negative anymore, it's going to be jump if 0, because we're doing this after the loop. So we've already completed one cycle of the addition before we test, so we need to stop at 0 now. Same thing here, jump if 0. Okay, this is what we're trying to test. But here is where my idea comes in. What if, instead of jump if 0, we say jump if positive, so that if it's positive, it jumps up here. If it's not positive, in other words, it is 0, then it continues on without jumping. That saves us some additional jump instructions. Now the only kink is we don't have a jump if positive command, but we have jump if negative. What if we made that number negative? How do we do that? Let's see. In this branch, the one we're bumping is input 1. So let's get the negative version of input 1. So how about this? Right now we copy from 0, we have 0 in our hands. How about we subtract input 1. So now we have 0 minus input 1, which gives us the negative version of input 1. And we're going to put that into input 1 so that this number is going to be negative. So if it was 1 originally, it becomes negative 1. And instead of bumping minus, we're going to bump up. So now we can implement our plan if it's negative. In other words, it's still not 0 yet, then jump up. Otherwise, we can continue. Same thing with the other branch. So copy from 0, copy to sum. Right now we have 0 in our hands. We're going to subtract. This time it's input 2. I'm going to copy it over to input 2. And now, instead of bumping minus, we're going to bump this up. Input 2. And then, instead of jump if 0, we can jump if negative. Remove the 2 jumps. Now in each iteration of the loop, we only have 1 jump to consider. We don't need to jump twice every time we go through this loop. Let's try it. You see this turning into -2, -1, 0. Come on, let's be enough. Be enough. Be enough. No! I need 2 fewer steps. 2 fewer steps. Okay, let's see what we can do. We're so close. Oh boy, I don't know, man. The only thing I can think of is this jump. After it jumps down here, it copies from and then output and then jumps back to the beginning. So I guess we can duplicate these up here so we don't have to execute 2 jump instructions. We can just do that up here and then jump directly to the top. That'll save us like 1 instruction. Let's do that. Copy from some outbox. Okay, that's what we have here. So now we don't need this jump to come down here anymore. This jump goes all the way up to the beginning. And yeah, realistically it'll only save us 1 instruction per set of inputs, and only if input 1 is smaller. So I'm not sure that it'll save us 2 steps altogether, but I really can't find any better ideas right now. Yes! Yes! Did it! Okay. Alright. I don't know if it was supposed to be this difficult, or I'm just missing some really critical idea. But yeah, this is definitely getting really challenging right now, which is a very pleasant surprise. So let's end it here and come back to the other levels next time. I want to end today's episode by revisiting the problem we had last time where we needed to multiply a number by 40. Last time I presented a solution that was based on binary numbers, but that was overly complicated. If you know nothing about binary numbers, then there was no way you could have figured out the solution by yourself. So today I want to present 2 alternative methods that are much more intuitive. For the first method, we can start at our final goal and work our way backwards. We know at the end we want to get 40 times a number, and our options are either to multiply what we have by 2 or to add 1 copy of the number. Obviously, multiplying by 2 will help us grow the number more quickly, and so we want to do that as much as we can. To get to our goal of 40x, we can find a way to get to 20x and then multiply that result by 2. So this reduces the question into how do we get 20x. In the same way, we can break 20x into 2 times 10x, and 10x into 2 times 5x. Now 5 is an odd number, so we cannot get there by multiplying by 2, and so we're forced to use our other option, which is to add 1. And so our 5x can be broken into 4x plus another copy of x. And just as before, we can continue breaking down 4x into 2 times 2x, and finally 2x into 2 times our starting number x. This gives us the same solution that we arrived using binary numbers. The second method is to build our way from the bottom up. To start, we know we can get to 40x by simply adding x to itself 40 times. This is a valid solution, but we want to make it faster by changing some of the additions into multiplication. We know we can get 2x by adding x to itself, so let's pair up all the x terms and combine them into 10 terms of 2x. We can multiply 2x by 2 again to get 4x, so let's repeat the process, combine pairs of 2x terms to get 10 terms of 4x. And once more, we will combine pairs of 4x's to get 5 terms of 8x. This time we end up with an odd number of terms, and so we can only combine 4 of those terms in pairs, while the last term of 8x will have to stay as is. This gives us 2 terms of 16x plus 1 term of 8x. And finally, we can combine the 2 terms of 16x again to get to 32x, and this is our final solution. Each of these terms, 32x and 8x, can be obtained by repeatedly doubling the initial number x. So let's make this in the game. This is the solution we had previously where it was based on the binary digits, but let's do a solution where we just do 32 times plus 8 times. So let's get the number from the inbox. We're going to copy it to, oops, that's the wrong spot. Okay, copy it to here. I'm going to add this, so now we have 2 times. it to here, add again. So now we have 4 times. Copy 2, add, now we have 8 times. Now we do want to copy it to 0 again. So at this point, 0 is going to be holding the 8x. Now we continue on, we add again, except this time we copy to another slot because we need to reserve the 8x for adding later. Between this, we have 16x. We just repeat this one more time. Add 0, copy 2, 1 again. Okay, hold on. Let me count because I lost track. If I add this, I have 2 times, 4 times, 8 times, 16 times, 32 times. I don't even need to copy 2 again. Add, add 1 first. Add 1 gives us 32 times. Now I add 0. So I have 32 times plus 8 times. That should be 40 times. Here's my outbox and the master loop. Hope this is correct. Yep, and apparently both the size and the speed are exactly the same, even though the instructions are different. So we're adding and copying to different places at different times. Apparently they both execute at the same time. So that's it for today. Thanks for watching. See you next time.